Amit, let us start.
Okay, sir.
It is
Shashank
90.
sir?
It is 99 and.
Sure, sir. Sure. Shashank sir?
Yeah.
Yes, good morning, everyone. Myself, Mr. Amit Sharma, an assistant professor in the Department of Computer Science and IT, University of Jammu. You're one of your local secretary for Disruptive and today's host. First of all, I welcome our today's speaker, Dr. Shashank Gupta. Good morning, sir.
Yeah, good morning. Good morning to all of you.
Dr. Gupta is currently working as an assistant professor in Department of Computer Science and Information Systems at WITS Pilani, Rajasthan, India. He received his PhD in 2017 from NIT Kurukshetra. He specializes in the areas of web security, Internet of Things, fog computing, blockchain, and UAVs. He is a core member of Disruptive Technologies (DT Lab). He is also a part of program committee of various conferences and journals and served as PI co-PI for sponsored research projects. He has also filed a patent recently related to HTML5 security. He has numerous publications in international journals and conferences, including IEEE, Elsewhere, ACM, Springer, Wiley, IJ Global, etc., along with several book chapters. He is also a professional member of IEEE and ACM. Now I invite Dr. Shashank Gupta.
Yeah, sure.
Please.
I'm sharing my screen with all. I mean, with all you people.
Sure, sir. Sure.
Please acknowledge, is my screen visible to all of you?
Yes, sir. Yes, sir.
Fine. Sir, is my voice clear? Can you
Yes, sir.
please
Yes, sir.
acknowledge?
Yes, sir.
Fine.
Yes, sir.
So we can start.
Yes, sir. You can continue, sir.
So again, very good morning to all distinguished faculty members, participants, and other students. So in this talk, uh, we will discuss the complete contributions of fog computing in the Internet of Things. But for that, we need to understand what exactly is this new technology for computing, which generally facilitates the Internet of Things to actually realize its real potential. Because we all know that recently the Internet of Things has produced n number of use cases which are very useful in our day-to-day routine life. I request someone of her, I mean, someone of you has still not unmuted. Can you please unmute from your side? Sorry, mute from your side because certain disturbance is coming. Please check.
Sir, everybody is unmuted, sir. You can start, Shashank, sir.
Fine. I forgot to unmute myself. I think now is the voice audible?
Yes, sir. Yes, sir.
Fine. So let us start from the beginning. So as I said, in this talk, I'm going to explain or highlight the key contributions of the fog computing in Internet of Things. Because we all know that Internet of Things has recently came up with certain use cases or certain real-time applications which are actually very useful in our, daily day-to-day life. And what is the role of the fog computing that we understand? Because Internet of Things standalone cannot give us the actual potential which we are using right now or which we are surrounded by right now. So we need to understand what is the real contribution of the fog computing, because fog computing is that thing which is actually facilitating the Internet of Things to actually realize its actual potential. But the irony is that Internet of Things has a lot of unprecedented data across the globe, which unfortunately are conventional data centers related to cloud or other edge networks cannot handle right now. That is the irony right now. And that's where fog computing comes into picture, because it is very easy for fog computing to handle this unprecedented amount of data. Unlike the cloud data centers or other edge computing networks here. This is number one. Number two, I'll also highlight some of our contributions in the recent, in our DT lab also, where students generally design and develop certain prototypes related to the Internet of Things, utilizing the concept or the infrastructure of fog computing here. So let us start here. Now, I quickly divide this entire talk into three parts so that you people remember what exactly we are doing in different in different modules of this presentation. So obviously, in the first part, I will explain you the complete logistics, the overview of the logistics of the IoT. Although it's been 2 days, you might be discussing various things about the IoT, so I don't want to dig deep into the IoT right now. So I'll simply explain certain few important points related to the IoT, and then we will clearly understand that what are the current issues or what are the current challenges in deploying the data centers of the cloud computing with related to the IoT, because that is the path which will take us to the fog computing. That is the actual motivation that why we are using fog computing still, yet we have the cloud computing available with us. So we understand very shortly that the people are deviating from the cloud computing and shifting towards new paradigm of fog computing here. So this is the part one. And once we have understood the challenges in the cloud computing, then we will completely explain what exactly is fog computing, what exactly its role in the IoT. We will exactly differentiate between these two guys, the fog and the cloud, so that we can really understand the motivation part, why we are moving towards the fog computing. And most importantly, we will discuss some of the recent use cases of the fog computing IoT, which are, some of our lab students have recently designed and developed in the Disruptive Technologies lab. And that's where we will also discuss what are the existing challenges in the fog computing infrastructure, because that would be the current problem statement or the future research prospects for the students to carry forward such research work in the form of the challenges in the fog computing here. And in the last part, I will try to correlate the existing contributions of the fog computing in IoT in combating the current pandemic scenario here. So we'll discuss what is the role of Internet of Things in controlling this pandemic, and apart from this, what is the contribution of drones, and most importantly, these related emerging platforms, ML, DL, and AI technologies, that how these guys are controlling the current pandemic here. So this is the overall roadmap of my talk here in 3 parts here. So let us start here. So first, we need to understand what exactly is disruptive technology, because we are talking about IoT and other emerging technologies, but we need to understand before that what exactly is disruptive technology. Any suggestion from your side? Any comment on this? What exactly is disruptive technologies? So let's be clear. I want this interaction to be a two-way rather than it's just a one-way. Otherwise, it will get completely bored. So let's be interact. So what exactly is disruptive technology? I request any of the participants, if he knows, he can simply unmute himself or herself and just throw the answer. What exactly do you mean by disruptive technology? Because this is the key technology which people are using right now, which we are using right now. Yes, any answers? Yes, please. I think someone has unmuted in between. Any suggestions? I don't want any formal definitions. No one? Come on, we have a huge strength of almost 100. Any guy, who can give, certain notions about disruptive technology. All right, let's then explain what exactly is disruptive technology. In short, it is very known, well known by the name of DT. Disruptive technology is a thing that really affects the normal operation of a market or an industry here. Let us try to understand with the help of a simple example. Long time back, we usually watch our, these movies and online things through the so-called conventional cable network here, through some, traditional or conventional cable service providers here. But now, in the current scenario, those conventional technologies of the cable operators are simply replaced with the web series or other these platforms like you people know yourself, Netflix, Amazon Prime, and so on. So what exactly these guys are? These Netflix, Amazon Prime, or other things have simply displaced the current conventional cable operator technologies and simply acquired an important place in the market. So it's a high time we should call these technologies as disruptive technologies, correct? So I mean, more about this disruptive technology. As I said, it displaces a well-established product, well-established cable operator, or any conventional technology, so that if new standard or a new industry or a new product will be created or deployed in the market and should be acceptable to everyone. And I mean, fortunately, we are surrounded by these technologies, disruptive technologies everywhere here. So this term has been first coined by a professor at the Harvard Business School. As you can see, his name, Clayton M. Christian. He invented the term. I mean, he's the guy who simply coined this term, that is disruptive technologies here. So my question to you people again is, do you think that the IoT is a disruptive technologies? Come on, guys, let's be interactive. Otherwise, this is going to be a very boring session. At least you can respond in yes or no. You are discussing IoT from the last, I think, 2 or 3 days. Yes or no? Is IoT, do you think, is a disruptive technology? Come on, guys. I need at least one response from your side. Yeah, so it is a disruptive technology because, yeah, please.
It replaces human in many places by means of things. Hence, it is disruptive.
Absolutely correct. So, I mean, we know that this technology has been acquired in the market by displacing so many conventional technologies. So, why we should not call this disruptive technologies, right? So, IoT is a disruptive technology, but it's not, guys, that in just one single day that IoT has become a disruptive technology. Right. I mean, let's say, IoT came into the market somewhere long time back in 1999 by this guy, that is Kevin Ashton. He's the guy who actually introduced the term, the Internet of Things, right? But I mean, immediately it does not turn out to be a disruptive technology because it is not very much acceptable by the people or the current infrastructure of the market where it is supposed to be deployed. So as soon as the year passes by, you can see the first internet refrigerator which we are using right now in some of our homes or in other infrastructures of our lab, that is LG was the guy who introduced the plan for the internet refrigerator. But still, I mean, in 2000, people did not call, or the experts did not call the IoT as the disruptive technology. Later on, certain robots we developed using the concept of the IoT, like this robot, which acquired a sufficient good place in the market. I mean, it's very well known by the name of the rabbit robot because it looks like a rabbit. So it generally forecasts the weather information or the stock market information. And finally, in somewhere in the 2008, the US National Intelligence Council declares the IoT as one of the disruptive technologies here. So, I mean, this is the emergence, I mean, how the IoT has been emerged as the disruptive technologies here. Fine. So, there are n number of other disruptive technologies, but right now, our focus is on entirely IoT, right? So, let us move further. So background of the IoT, I mean, simply we know, I mean, so many statistics we have that somewhere in the 2020 or later on, I mean, people would be less, but the more connected devices we can see, as you can see from this scenario here. Even this picture proved to be wrong right now, but it is increasing exponentially here. So it's a high time that we should look at this guy, that is Internet of Things, more seriously, because it is creating so many other problems that we have to handle, I mean, soon on this point of time. Yeah, I think someone has unmuted himself. Do you have any question, any suggestion? All right.
No,
fine.
sir, sorry, it was by mistake.
No problem. So let us see quickly what exactly is IoT. So as I said, it's been 2 days. You might be discussing few about IoT, so it's nothing new about it. But let's put some key spotlight on what exactly is IoT. So again, I should ask to you people, I mean, what exactly is IoT, do you think? In just, I mean, suppose, I mean, we are layman sitting right now, so we don't know what is IoT. Can someone explain in one single sentence?
Sir, may I?
Yeah, sure, please.
So actually, morning. I am actually Anirban Datta from West Bengal. So actually, what I have understood, although I am not from computer science background, it is actually the communication between devices without any human intervention through the cloud.
Correct. Absolutely correct, sir. Thank you.
Thank you, sir.
Thank you so much. So again, I mean, this definition is absolutely correct. So IoT is Internet of Things, as the name is itself indicating its significance, that it connects the physical objects. Physical objects which are surrounded, which are embedded with the sensors, with the actuators, and so on and so forth, so that the multiple these objects can communicate with each other, can share the data with each other seamlessly, right? This seamlessly is very important because we do not need any obstructions or any obstacles in the Internet of Things here. So again, in just one go, what is IoT here? I mean, anywhere connection, despite of any place, it is location aware. It is anything. I mean, you can connect anything, anytime. So if I'll say anywhere, so that means on the outdoors, indoors, even at your terminals, in your conventional homes or smart homes, wherever, it doesn't matter to me. I mean, IoT says like this, that I'll give you the connection anywhere. On the travel, I mean, daytime, I mean, nighttime, anywhere, or anything most important. I mean, it is not restricted. I should say it is not restricted to the set of some terminals. It can be happen between certain terminals like PCs. It can be human to human deployed with certain sensors. It can be human to terminals, terminal to terminals, machine to machine. So IoT is this guy. I mean, nothing else, right? Now, there are certain IoT visions also that we have to ensure. Like we said, that IoT devices should have this vision of the things, that what exactly is required. So we need RFIDs, we need NFC cards, we need, these cyclotic intermediate sensors, objects. And we also need the underlying technologies like, the communication technologies, WAN, LAN, Ethernet. And most importantly, we need the semantic vision also. Like, in which context these guys are communicating with each other, right? Because it is not, interoperability and the heterogeneity is a huge factor in communication or in establishing a good communication between each other, right? So these are the key elements. One should remember while designing and the development of certain small prototypes when actually he or she used to be in this scenario. Now, let us put some spotlight on the layered architecture, which is a very benchmark architecture for the IoT. Like we all know, the OSI model layered architecture and other, this Internet Protocol layered architecture. But IoT is again explicitly coming with its own layered architecture. So let us see one by one, because again, as I said, the name is itself indicating the meaning of the layers itself here. So you can see in the first, we have the object layer where we have to understand the deployment procedure of the sensors and the actuators and so on and so forth. So we need to understand what are the data acquisition systems we are going to deploy, what are the sensors and the actuators we are going to deploy. Like temperature sensors or moisture sensors in every with respect to any use case here, right? The base layer. Obviously, once we have deployed this, we should know that which transmission technology we are going to use between these guys, right? 3G, 4G, LAN, Ethernet, and so on and so forth, right? Once this is established, we need to understand that what sort of service layer we are going to use. Like we people are very well known with the cloud data centers, or we will use our own repositories, or we will use the concept of ubiquitous computing like we do in mobile computing and all, right? So this will act as a somewhat a middleware between the object layer and the transmission layer here. And finally, we have the application layer where we are sitting right now, and we need to understand that which application we are going to design and develop, whether it is related to some agriculture or precision agriculture techniques, whether it is related to healthcare, smart, this grid, anything that will come in the application layer part. And finally, this is the business layer, I mean, which we very well known by the business layer, where again we are sitting right now. The people who are going to use this technology, some other things which I mean are non-humans, like in the form of certain flowcharts, graphs, or whatever the data analytics you are going to use here. So this is the complete, I mean, layered architecture, which was I mean, long time back coined by the Albert, I mean, who is known to be the father of the IoT here. I hope this is clear to all of you. I mean, nothing more complex, but I don't want to dig more into it. This is just the overview of the IoT layered architecture. So this was the complete logistics, I mean, the overview of the IoT, guys. I mean, if you have any question, any suggestion, please, I mean, throw the questions on me, and I am ready to take your questions here before proceeding further. Anything which you haven't understood or which you have anything you want to make, please let me know. Fine. So let's continue. So assuming you do not have any problem till now. So now, as I said, in the first half of the presentation, till now, we have just understood what exactly is IoT, this layer architecture, and some of its logistics in an introductory form. Now, let us understand what exactly is the key role of the cloud computing in IoT. I mean, can't I do this as a standalone thing? Do I need this guy? And if I need this guy, is it still the real thing to use it, or is it replacing something? Because I probably might be facing certain challenges in the current designing and the development of the use cases, right? I mean, we all are surrounded with our so-called online e-commerce websites. So probably cloud computing is not used by these people to provide you the actual services, right? So that is we are going to discuss. Yeah. So we all know what exactly is cloud computing, guys, right? But still, just a quick feedback. So I mean, cloud computing says that you just pay me and I will give you the resources. You just pay me and I will store your actual resources on some individual data centers, which are somewhere located at the core network of the cloud computing. You need not to worry. You just deploy your web application and just deploy our web application, your web application on the cloud data center, and everything will take care. This is what, in just informal way, to explain the cloud computing here. So data is stored on the multiple servers and can be accessed online from any device, informally, right? A model which provides on-demand network access to the shared computing resources. I mean, you will not question on such things, right? So I am a model, cloud computing says I am a model, which will facilitate you with certain access to the shared computing resources by XYZ people, right? Pay-as-you-go model, I mean, very well known by this technology. Pay-as-you-go model helps the users to conveniently access the remote resources, right? And obviously, it will offload the burden of load of actual, I mean, people who are actually retaining these things, and they say, okay, we are ready to pay, and someone will come on our behalf, and he will simply deploy the actual resource, and people will access the resource from cloud data centers here. And that will also boost the scalability, power issues, and other energy efficiency issues also. And we all know these are some of the examples: IBM, Amazon, Google. These are nothing but some of the recent cloud, I mean, the existing cloud providers here. And IoT also need cloud computing data centers, because it says that as we discussed in the layered architecture, that somewhere in the business layer, we need the data storage mechanism. We need the some computing mechanism where not only data storage will happen, the computation will also happen on that data centers, on those data centers. And that computation will be further redirected to the application layer devices, will be redirected to you people, right? Where you people are sitting right now, without knowing that who is computing these things, without actually sensing what exactly is happening at that data center. But IoT says again that I need these computation, someone should hold these computation on their platform. So cloud computing says, I am the best guy for you people, right? So we need to connect this particular thing with the IoT here. So let us quickly go through the layered architecture, like we discussed the layered architecture of the IoT. So probably I'm assuming you all know about these three technologies, that software as a service, platform as a service, and infrastructure as a service. And again, the name itself is indicating their meaning here, that at the lower level, we have to, the cloud usually provides someone the infrastructure where everything is going to be deployed and where everything is going to be compute, so that certain useful information can be redirected to the application layer. And we better call it as a infrastructure as a service, right? So I need n number of cloud data centers. The customer will say, for deploying such web applications. So cloud data center has to provide the service, which is very known by the name of infrastructure as a service. And obviously the administrator of cloud data center or even the user can handle such computations on this platform. Once it is done, then I need also a platform as a service, that which platforms I'm going to utilize or integrate as a part of their computation here. Do I need some proxy? Do I need some middleware? Do I need to perform some runtime computation? Do I need to run some other, everything which with respect to the development part here. And we very well known by the name of this platform as a service here. And lastly, again, at the application, close to the application layer, we need to deploy the actual application software, which involves the business logic, which is required at this particular system here. And finally, here we are sitting where we are actually using this technology without knowing about whether they are existing. We just have a feeling that they are just simply virtually present. So this is just the layered architecture of the cloud platform. So one more time, in a different way, cloud infrastructure. This is, let's say, this is where we are sitting right now, right? We have, let's introduce, this is the application layer, close to the ground level, where we have introduced the application and the other things. And this is my cloud data centers, the cloud infrastructure, which can be accessed through the internet here. So this is again further divided into two modular ends. One is the front end and is the back end. One another way of understanding this entire infrastructure here. Fine, guys, everything is fine up to this point. Let me know if any issue till this point. Great. So now it is a high time that we should understand that what are the issues of cloud computing in using in using the technology of IoT. See, remember, I'm not claiming that every IoT use case or every IoT application doesn't use the cloud computing. But there are n number of other contexts, and I say more number of contexts rather than which I'm explaining right now, where cloud computing is no longer required. He cannot, as I said in the very first introductory slide, that we have huge quantum of unprecedented data, which our conventional cloud data centers cannot handle. And we'll understand this statement and we'll justify this statement now very shortly, right? Because that will take us to the fog computing. Unless we will not understand what exactly is this, then there is no need to move to the fog computing. I'm okay with the cloud computing part. So, understanding the key architecture and the layered architecture of the cloud computing, and what exactly is the do's and don'ts. So let us understand what exactly are the issues here. So the first issue which I have highlighted in front of you guys, that it is not practical for latency sensitive applications. Can someone put some light on it? If someone knows, if someone has understood, what exactly is this? Why cloud computing platforms are not feasible for latency sensitive applications? So what do you mean by latency sensitive applications? Come on, guys. Any answers, any responses from your side? Any guesses? Come on. Don't think whether I will be wrong or right, doesn't matter. At least you should respond. That is the first step you should take. Come on, guys. I'm not going to move forward sometimes because I need at least one response from your side.
Hello.
Yeah.
Sir,
Yes.
sir, can you repeat your question again?
Yeah, so I'm saying that this is the first highlighted challenge for the cloud computing and in IoT. And the first challenge says that the cloud computing is completely not practical for latency sensitive applications. So what do you mean by this? This is my question. How will you justify this if you understood what is the latency sensitive applications?
Okay, sir. Sir, I think we can deploy different types of sensor in a remote area. So at that time, we can say it is not a practically for latency sensitive applications.
So what is latency sensitive applications?
That means availability of availability of data.
In a real time scenario, correct?
Yes, in a real time scenario.
Yeah. Thank you so much. Thank you so much. Any other response on this? Any other
Hello, sir.
Yeah, anyone, please.
Hello, sir. Myself, Prakash, sir.
Yeah.
Sir, the latency applications there are something in real time. The data availability, there will be delay in data availability.
Correct. Absolutely correct. Yeah.
Yes, sir.
Yeah. So I got enough responses on this. I mean, this is
Hello.
what I require. Yeah, please.
Sir, one more situation is there. If we are performing a remote, operation, surgeon is performing a
Correct.
remote operation. So at that
Correct.
time, it should be real time. The functioning should be in real time because
Correct.
it is a critical situation.
Yeah, understood. So the something is stored remotely and that too in a critical situation. So that will also come under latency sensitive application of umbrella, right? All right. So let us try to put some more light. So all the responses are more than correct for this. I'm sorry. So cloud computing says that I'm infeasible for latency sensitive applications. So we need to understand what exactly is this guy. I mean, I'll simply write one application or a use case in front of you. You just respond in yes or no. Do you term healthcare use case or healthcare, any e-healthcare, smart healthcare application under the umbrella of latency sensitive applications? Yes or no, guys, on it?
Yes, sir.
Fine. So now, again, we need to understand here that cloud computing is not practical for latency sensitive applications, for applications like healthcare and all. Why? Because healthcare applications or latency sensitive applications demand real time processing, demand accurate processing, right? So cloud computing says, we need to understand that we are sitting somewhere here at the application layer. And cloud data centers are somewhere here, which we usually call the core network, right? So suppose some healthcare application is deployed here, and he needs the service from the cloud data centers. So he has to travel this much distance, guys, right? This much distance, and again he has to come back. So here the latency, I mean the delay, we can't accommodate in such applications, right? So the point here is that the cloud computing is obviously good for, scalability and other issues and other, data storage capabilities, but it is creating a huge distance with us. And it is not good for healthcare applications, for smart transportation, where we require the response within few fraction of seconds, or within few fraction of, let's say, nano or microseconds. So cloud computing is not best option in such applications here. Fine. I will put some more spotlight in the upcoming slides, if some of you have not still understood the fact. Second thing that, as I said, the first point in the introductory slide here, that we are using the concept of the IoT for introducing, for developing the applications related to smart healthcare, smart grid, smart transportation, smart water, and so on and so forth. And unfortunately, we are creating enormous amount of data at the edge network, or the network which is closer to the very application layer. So it is very infeasible to handle such data on the cloud data centers here also. So that is also another issue here. And other issues related to the, challenges continued, greater demand for bandwidth. So do you think this justifies our previous point? You see, I'm traveling a huge distance and I'm getting the response. So obviously, I am not optimizing the use of the current bandwidth, right? I'm not optimizing the use of the bandwidth. So you will see if I'm using the cloud data centers for such real, time latency sensitive applications, there would be a huge loss of the bandwidth also. The huge demand for the bandwidth also required. Unnecessarily, you will see a huge congestion there. Low latency, which we already said, that the goal is to achieve the low latency, the low delay, right? Try to understand this point. And that is not the cup of tea for the cloud computing, unfortunately here. And obviously, there are a number of security issues as well. So these are some of the explicit challenges in the literature art, which cloud computing are suffering right now. Guys, so again, I'm ready to take questions before moving further. If you have not understood anything with respect to the challenges in the cloud computing, let me know. Otherwise, there is no need to move further. Please let me know. Any suggestions, any comments, any questions, any queries? Seems better then. So we can move forward easily then. So here comes the fog computing in IoT. So this guy has been simply replaced with the cloud here. Now the first thing, why this guy is called as fog computing, right? Why this guy is called as fog computing? That we'll understand. And obviously, it is quite possible that without even explaining fog computing, why is it called so, you people actually understand why is it called so without even explaining, from my side here. Second part, we'll exactly understand what exactly is fog computing, how is it resolving the challenges faced by the cloud computing, and then we will see what are the main applications, the latency sensitive applications we can build, we can design and develop using the fog computing in IoT. This is our next goal here. Fine, guys? All right. So the need for the fogs. Already we discussed this. So let's do it one more time. So it is claiming, fog computing is claiming that I'm going to address the issues like high bandwidth requirements, low latency requirements, and privacy sensitive applications also. Nobody wants that my healthcare data should be redirected or should be replicated to my opponent or to my other guy here, right? So these are the issues this is going to address here. So what exactly is fog computing? FC in short. So let us try to understand, instead of asking you people right now, so let us try to understand. It says that I'm going to bridge the gap between the cloud data centers and the end devices, which are termed as your IoT nodes or the physical devices at the application layer. Bridges the gap. That means it is going to create a bridge between you people, between your IoT nodes and the cloud data center, which is sitting somewhere at the core network, two-way long. And obviously, the life becomes very easy for us here to access those resources here. Still, let's try to understand more properly. It says rather than a vertical system architecture, I'm going to be a horizontal system level architecture. And that will prove why it is called as a horizontal system architecture. And most importantly, as I said, that fog computing is just introduced. The only goal, the only aim in his mind to give unconditional support to IoT devices, to the IoT network, to people who are using the actual real world use cases of the IoT. Fine, guys. So without explaining further the formal definitions, guys, let us put focus on this picture here. We people are sitting somewhere here at the application layer. We have a number of mobile nodes in different clusters, including, let's say, IoT nodes as well, IoT sensors and actuators. And this is where the core network of cloud data centers here, right? And this is one more data center, which usually sometimes cloud access for some more data storage, for some more information here. And this is where, guys, where fog computing is coming into picture. Some more introduced in facility here, which we also known by the name of edge layer, or I mean, again, the fog layer also. This middle guy. So you can understand here that fog is nothing. It's a virtual cloud, which will do what? It will reduce the communication gap. It will bridge the gap, and it will consume the optimized use of the bandwidth and other latency issues. So what exactly will happen in this case? That, yes, is there any problem? Is there any question? I think someone has unmuted himself or herself. Yeah, fine. So here, that we need to understand what exactly is this fog layer or fog computing layer is doing here. As I said, that fog is nothing. It's a virtual cloud. That means it is again a cloud, but a virtual cloud, which act as an intermediary between you at the application layer and the cloud data centers. So it acts as an intermediary, it acts as a proxy between you people and the cloud data centers. So what will happen, assuming that your IoT node initially requires something from the cloud data center. So he will request from it and he will send to him, right? Now, instead of straight away sending to him, he will also create a copy in the fog nodes as well. Just like a cache, right? As I said, fog is nothing but a virtual cloud. And later on, suppose if this guy is asking for the same resource, so he need not to go to the cloud data center. He can simply contact the nearest fog data center, the fog device. Fog device could be anything. It could be any terminal. It could be any your server. It could be any computing device. Understood this point, guys? So you see, the communications distance, which was very large, it eventually got reduced, right? And when this got reduced, so many things are already resolved. Bandwidth consumption is optimized. There is no need of higher bandwidth, right? Latency is resolved. Low latency we are achieving because this fog is very close to the ground level, close to the application layer, and that is why it is known as edge layer also, because it is very close to the edge of our ground level here. Understood this point, guys? That why fog computing is actually playing a key role here. And obviously, we have the security issues that we can deal later and separately. Right now, we need to understand the key issues, specifically the latency, the delay issues, and all. Unprecedented amount of data here. Fine, guys? And now, the term which we have coined, why it has been termed fog computing? Because, I mean, you know, in real world scenario, how fog gets generated on our this ground level. So generally, we have the cold air which is touching at the ground. So this vapors get transformed either into a cold ice or into the cold water, and which get evaporated above in the air, rising from the down to the earth level to the upper layer. So we call those small clouds which are touching our ground as fog, right? And that is why this guy is very close to us, close to the IoT nodes, right? So this is called as fog nodes, fog computing. Guys, now again, I'm ready to take your questions. Anything if you have not understood with respect to the fog computing part. Any comments, any suggestions, anything? Fine, great. So let us move forward because now we have understood the infrastructure settings of the fog computing, right? So someone will ask you what exactly is fog computing. You can simply respond to him. It simply acts as an intermediary between the cloud data centers and the physical world of IoT devices, from which we can introduce the low latency and the optimized use of the bandwidth here. And also, you can see we can distribute the data among different fog nodes here. And most importantly, which I have not termed later, it also supports the mobility issues which cloud cannot handle. I mean, you can use your mobile and you can create, your virtual fog nodes while in moving nodes. Right? So many things which are actually needed for the use cases which demand low latency. Right, guys? So here, cloud data centers standalone cannot produce such applications. So they need to utilize the capabilities of the fog computing. So another infrastructure of the fog computing, which one of our recent lab student has developed using the edge devices also. I mean, you can see up to here is the fog layer. This is the physical layer of IoT devices, which is surrounded by different clusters. And this is the actual cloud data centers here. So you will see n number of infrastructures of fog computing. Everyone can change their infrastructure settings, but the underlying terminology will remain the same, that this guy will always act as a virtual cloud, as an intermediary. Correct? And this is just like we saw the layered architecture of cloud computing. The same architecture is also for the fog computing here. I mean, just the names of the layers has been interchanged. Other processing and everything is same here. Fine, guys. So because we need to come to the important part here. So this is entirely the same thing. Now we have one more computing which is known as the edge computing, which is almost similar, as I said, to the fog computing here. It says that it refers to the local network where sensors and IoT devices are located here. Fine, guys. I mean, if I go back here, so which is my edge network? So I'll say, where my, this computing devices are located. So this would be my edge network. Why it is called edge? Because you can see it is very closer to the ground level. It is very closer to the application layer. And that is why it has been termed as edge layer, edge computing here. Right? So located at the edge of the network near IoT devices. Near, very close to the ground level, unlike in the core network of cloud data centers here. So usually provide the computation and the storage resources close to the user in open standards and ubiquitous manner. So earlier your computation and storage happens too far in the cloud data centers. But now you are using your mobile, you are using some Internet of Things device, and your computation and storage is very closer to you. Come on, guys. Right? So it becomes sense that it can handle the latency sensitive applications in large amount, and that too in movable form. Right? You can use the concept of Internet of Vehicles, which are already connected and in moving. They can also handle the fog computing. So with cloud computing, we cannot introduce the use cases of Internet of Vehicles. Right? So integrate the IoT devices with the cloud here. Now, fog versus edge here. First of all, so nothing much. Fog computing is hierarchical. So earlier I said it is a horizontal system architecture. I termed it somewhere here. It is a horizontal system architecture. Can someone justify why is it a horizontal system architecture rather than a vertical architecture? Come on, guys, because this is already indirectly explained to you why it is horizontal architecture rather than a vertical architecture. Any response?
Sir, this Gajendra Singh.
Yes,
Sir,
yes.
I think we can add
Yeah,
more number of resources. That's why.
correct. We can add more number of clusters, and in that we can introduce more nodes, and in that we can introduce more resources, and that will introduce the mobility that will resolve the mobility issues. But cloud data centers, that I am a vertical, I will not introduce the scalability in a horizontal manner, in a moving manner, right? So guys, remember one thing: whatever the online social networking websites, the e-commerce website you are using right now, they all are following the concept or the infrastructure settings of the fog computing, right? Everything is in front of you. Edge computing is limited to computing at the edge, right? Simplifies the communication there. Now the bigger guy, cloud versus fog. Come on, guys, we already explained so much on this. So we are in a position to actually differentiate between these two guys. That is the cloud versus fog. Yes. So what is that? You can see cloud will always become under the centralized setup. And you know, I do not need to explain to you people what are the limitations of this centralized. But here, this guy says, oh, come on, I am decentralized, I am distributed, right? Latency is always high, low latency. Low mobility, we are not claiming that total no mobility, but very low mobility. Mobility is at par. The use cases, the applications like Internet of Vehicles, smart transportation, which demands high mobility, are all supported by this guy rather than this. Low bandwidth cost, obviously the communication distance is reduced. So why I need higher bandwidth, right? And low storage capabilities, obviously, because I can make different clusters here. And these are some of the common advantages. Computation, this is also doing the efficient computation, and it is also doing the efficient computation. The security infrastructure which I can deploy here, I can also deploy here. And I can also pool the resources as well. So guys, I think this is clear to you what exactly is the difference and what exactly is the contribution of the fog computing over the cloud computing here. Fine, guys. Any question, please let me know till now. Fine. So let's jump to the use cases of the fog computing in IoT, because already we understood the cloud computing limitations and the fog computing, some of the miracles here. So let's jump into some of the use cases of the fog computing in IoT. And I'm going to highlight some of the use cases which our recently lab students have designed and developed. And obviously, I will not dig deep into the use cases due to certain other constraints, but obviously I'll make sure that you will understand the key contribution of those use cases. So let us try to see first thing in a generic way, what we have actually, in a different way. So we have right now the smart classrooms we are doing right now, Internet of Vehicles, other positioning system, this thing. We have the things with respect to the precision agriculture, smart agriculture, air quality monitoring, healthcare, right? These assisted for elder assistance, assisted devices like drones and other things, smart home capabilities. So remember, cloud computing cannot give you these applications, as a standalone commodity. Fog computing has to intervene, and that too in a greater quantum, in a greater capacity, in contrast to the cloud here. Fine. So let us see one by one. So recently, one of our lab students has created developed one healthcare prototype for these Alzheimer patients and some elderly patients who are, unable to remember after a certain period of time, and we better call it as a Alzheimer disease. So you see, again, without understanding the key technical concepts, the logistics, the infrastructure is entirely same, guys. So we have the physical world of IoT devices, correct? We have the fog layer here, we have the cloud, and we have the actual user who is actually monitoring and these particular things there, right? And so many other things. I mean, you can see this guy is embedded with so many sensors and all, which we actually need for doing here storage and computation and all. Fine, guys. This is one thing which we, and obviously, I mean, again, I need not to repeat myself. I mean, this is a highly latency sensitive application, highly latency sensitive. So cloud cannot fulfill my job here. So this is one another, I mean, this almost the same thing, but just the abstract view of, but this is in a wide body area network here. And recently, our student has contributed in this specific journal here. So again, the same thing here, but this is only specific to the wide body area network, where people are using the capabilities of the, I mean, BLE networks and the Wi-Fi technologies, and they are using the same things in 3 different phases, like the data acquisition phase, the data interface, and the data integration. So you can see only the name has been changed, but the entire logistics and the integration part is similar. So we need to perform the sensing, right? We need to give the data to the, I mean, fog and the cloud, and later on we can manage the data from these devices, which are in moving also, which are executing the mobility operations also. As I said, that apart from the goal of the latency sensitive application, that the latency has to be very low, we also think about the security and the authentication issues, because standalone, if we focus on the latency part, that is not going to work. So we also focus on the security part by deploying certain cryptographic algorithms and all here. This is again one benchmark model, I mean, generic security model for healthcare applications, where we are actually, after introducing the low latency, we are focusing on the security constraints also. So for security, we generally try to achieve the security through the cryptographic, these public key infrastructure available tokens, which we can acquire from the library of the PKI data here. So you can see each and every security concern we are handling with the tokens, which can be act as a nonce for you people. You might have studied in your courses as well. So these are something more than that, but obviously provide the same level of security in higher quantum. So we have some more use cases apart from the healthcare systems also. With respect to the retail management, I mean, we all are dealing with such things, like your Amazon, I mean, Myntra and all. So all are using this particular concept of the cloud and the fog here. So this is just the abstract view, you can see. So we have the RFID systems, which are deployed as a smart inventory system, and these people are checking it out, what exactly is happening with respect to the other operations like advertisement, tooling, retailing, and other logistics, or other also business analytics. So this part will be handled by, I mean, the ML and the deep learning, where a lot of analytics we can do, because again, fog and cloud standalone cannot do the analytic part here. So for analytics, we need to utilize the concept of these machine learning and the deep learning approaches there. Similarly, we have the efficient waste management in smart cities scenarios here. So you can see, I mean, a lot of government bodies can synchronize among each other using the existing infrastructure settings of the cloud and the fog, so that they can actually perform the latency sensitive criteria, and they can actually perform the, they can actually fulfill certain security constraints as well. Yeah. So you can see, this guy, the middle guy is all together connected with each and every thing from here. It has to actually concerned here. So he's actually interacted with the, let's say, mayor of the city council, manufacturing plant, recycling plant, and also most importantly, the health authorities, which are involved in collecting the waste around our cities and all. So we are also connected with the garbage bins, where this particular, the GPS sensors and these isometric sensors, and apart from that, the soil moisture sensors we have embedded, so that every data we can introduce onto the cloud in conjunction with the IoT. So this was a small prototype which our lab student has recently developed in our campus, where actually each and every body is organizing, is coordinating among each other to just ensure that everything should happen virtually in a smartly manner. This was related to one of our activity related to the precision agriculture. You all know about the precision agriculture, which very well known by the name of nowadays smart agriculture, where everything is done using the concept of the IoT mechanisms. So soil moistures are embedded inside the soil for calculating the soil moisture content. Here we have the actuators which actually activate the irrigation valves and the controllers. So this was one of our recent contribution in the form of a smart water management. So again, lot of interconnected bodies are connecting through these data centers. And most importantly, which I am not explaining you right now, that apart from this, we are also doing a huge quantum of the analytics also, because it's not, these are just the platforms. The ultimate analytics has to be performed on using some certain these embedded or ensemble deep learning approaches, because we have to generate the responses so that the better picture should be delivered to our clients and all. So this was some of the use cases here. And again, we have the similar set of scenario, which is completely the fog centric. So here we do not require the actual cloud. This is completely fog centric here. So here you can see in a generic way, we have each and every application which are sitting at the application layer, and the user is also monitoring at the application layer through the standalone cloud computing system. And in this particular scenario, each and every function we are doing with respect to the resource provisioning and the task scheduling. So that is all handled by the complex reasoning task of the data analytics. Fine, because as standalone, again, I must say, so we are moving away from the fog computing now towards the data analytics part in the role of, with respect to role it's in the Internet of Things there. Now, what are the challenges of the fog computing in IoT? Because this is a big question again now. We started with the challenges of the cloud computing, and we saw how fog computing is overcoming those challenges. Now, the big question is there any challenges in the fog computing? The answer is completely yes. I should not ask you people as well. The big question is, what do you think? What should be the challenges in fog computing in IoT? Come on, guys. Because somewhere directly or indirectly, I have already explained you that because fog computing again is dealing with certain situations which obviously he can't handle. Come on, guys. I need certain responses at this point of time. Challenges, issues, anything. Responses. I need responses, guys. When I'm saying I need responses, that means I really need responses, because whatever we have explained earlier, that is the overall outcome. Otherwise, there is no need to move further again. Come on, any responses, doesn't matter valid or invalid. Everything is valid as long as you are responding. Come on, guys, how many times you want myself to repeat? Come on, at least one student can respond. Challenges. No one? Yes,
Hello.
yes. Yes.
Good morning, sir.
Yeah, please.
Sir, power consumption is a challenge, will be a challenge for the computing nodes in fog computing.
Power consumption challenge is obviously going to be handled by the standalone IoT nodes itself, because What is IoT here? Because with the less power consumption, they have to perform. And if the less power they are not performing, so we will not term this as an IoT device, correct? So
Okay, sir.
let us assume that these power and energy efficiency issues are itself handling by these nodes itself. Anything apart from power consumption issues?
Privacy.
Yeah, sure. I did not hear clearly. Someone said something.
Privacy in
Privacy, again, let's say security issues that we can handle, and obviously that is the challenge. Yeah, we can term it as a security issues. Obviously, cannot be handled, so we have to. Another important challenge, which I am expecting from your side, hasn't come yet, because that obviously is the drawback of the fog computing.
energy consumption.
It support
Support for
it supports low bandwidth. It's a costly.
I mean, this is a reverse. So if it is supporting low bandwidth, so that is the advantage, I think, because we are not supporting the higher bandwidth constraints, right? We
But
are moving from high bandwidth to the low bandwidth.
but sir, if we need high streaming data, continuous real time data, at that
Correct.
time the
Yeah, at that time, so we are doing everything not standalone. We have the in conjunction with the cloud as well, the connection. So high bandwidth issues can be easily resolved in this infrastructure.
What about energy consumption?
Energy consumption is again another issue, right? Because we have to understand the, I mean, like earlier guy has said, the power consumption and other things. So it's another issue here. So let us highlight, as someone have you said, security issues, data analytics part. Now, this is not with respect to the machine learning or the deep learning part. I mean, obviously, this is something with respect to that, but fog computing cannot provide you the data analytics part here. Considering one example, we are dealing with the latency sensitive application, let's say healthcare, e-healthcare system. And we are ensuring that we are following the existing underlying infrastructure of settings of the fog computing, correct? And obviously, we are getting the response in real time with very low latency and all. We got it, right? The goal is achieved. But still, healthcare device is still struggling from one more thing. What is that? Whatever the data we are generating with low latency, with low detail, with low delay, that is acceptable. But who is going to authenticate that data? Who is going to check the accuracy of that data? Yes or no, guys, on this? Come on, at least say yes or no.
Yes, sir. Yes, sir.
So who is going to, conduct certain measures which will actually look at the accuracy of the data? So that's where the data analytics come into picture, right? So this is one of the key challenges here, right? Obviously, again, resource management. Because every IoT application or use case has a bottleneck or has a upper limit with respect to its scalability and the resource management issues here. But most importantly, which we are highlighting, is these two guys, which encompasses the energy efficiency issues, security issues, and most importantly, the accuracy of the data, right? How much data is accurate, right? That we have to understand. So that is the main challenge in the fog computing, which people are right now working, in as a part of their PhD work or other things here. So this was all related to the guys, my contribution with respect to the fog computing in IoT here. Now, I'm redirecting this talk somewhere to the current pandemic here. So initially, in few slides, I'll give you the background of the COVID-19, which we are all familiar with right now, some statistics, and then we will quickly jump to the, what exactly is the role of IoT in combating the COVID-19? That is the overall goal for this. Fine, guys? So let us talk about the timeline of the COVID-19. We all are familiar with it. So it started somewhere around in late in December 2019, and we all know how it propagates till, I mean, April 2021, and even we are right now in June here. So, I mean, is it something fog computing and IoT is going to play a key role in this particular scenario that we are going to discuss? The corona transmission levels. So, a lot of people are now technically representing the things of what is the propagation level of the coronavirus, this pandemic here. So you can see in the index level, we have the single guy and how it is disseminating the disease exponentially. Sorry, I'm so sorry. Exponentially, and which we call it as a red alert in some mechanism. Fine, guys. And these are some of the techniques. I'm just quickly recalling that, these are the techniques which people are usually using very frequently for collecting the certain traces of from our body to just detect whether it is a false positive or is a false negative. So most very often, I mean, in our country, usually people do this, but in other countries, I mean, people are following other scenarios related to the nasal aspirate or this endoscopy aspirate and other things also. I mean, most importantly, they are also following the blood test samples also. So as of now, we all know the non-technical preventive measures which we can take through the COVID-19 preventive measures, that practice the social distancing as much you can, which is considered to be the hub here. Wear the mask, wash hands as much you can, and avoid the social gathering indoors, outdoors, and stay as much as home, because we feel to be privileged at home right now. Now, we'll take this talk towards somewhere that what are the sectors which are hardly hit by the coronavirus pandemic, and what exactly is the IoT role where it is playing here. So, I mean, these are self-explanatory things. So, you know, the aviation industry is the largest guy who is, I mean, very much hit by this. The indirectly, the tourism also, the construction labor also, and not only labor, the bigger players who are involved in the construction, I mean, policies also. Apart from this, the oil industry is also due to completely restricted travels or lockdown restrictions, and healthcare facilities also, I mean, shortage of health equipment, and you know the rest of the story here. Food supplies also, the sectors which are hardly hit by the pandemic, they are also dealing with the same scenario here. Telecommunications, heavy traffic issues with respect to the, I mean, underlying connectivity, underlying infrastructure of the internet, and other downsizing organizations or compromised network reliability here. And obviously, we have certain drawbacks. Obviously, the public rumors, the postponed announcements, shortage of certain resources in the form of such kits and other things. Yeah. Now, where these things are now being handled by the current disruptive technologies here, that we have to discuss here. So, what exactly is the role of IoT in handling the COVID-19? That we need to understand here. So, I'll just explain you the overview, the infrastructure of one framework which exactly does this in controlling or in combating the COVID-19 using the IoT concept here. So again, you can see everything is evolved here. The same structure, the same fog computing layer, cloud layer, and even this is our application layer and the network layer we are using. And apart from this, we are also introducing the data analytics part, so that whatever the data we are getting, that should resolve in multiple scenarios with respect to its accuracy, classification, and other constraints also. Yeah. So the model shows, I mean, the various layers, I mean, such as perception, network, fog, and cloud layer. So each and every layer, I mean, has its own, I mean, logistics, which we have already explained. But the only thing is that, I mean, it's only about the data and its accuracy, that how we are going to handle with respect to this particular scenario here. So this is the explanation. So I mean, just we have already explained indirectly. So that is, cloud will be acting as a centralized server for storing and retrieving the data. And obviously this will take the charge that cannot be computed by the fog computing layer, because this is the main commodity. Because firstly, all the data which we are getting from the patients, that has to be resided initially at the cloud data center. And then at the perception layer, using the embedded RFID tags and other sensors and the actuators, we have to sense the data, and we have to understand or interpret the data using various algorithms of the these data analytics part here. And obviously the network and the fog layer will do their own job with respect to the networking and underlying communication technologies. And whereas the fog layer has the integrating capability with the IoT sensors, which we have already done here. I mean, the main mobility and the latency and the bandwidth part will be handled by the fog layer here. And these are some of the tasks, which directly or indirectly are controlled by the IoT. Not again standalone, using some drone, surveillance systems. And obviously the data analytics and the AI part will come into picture. The quarantine surveillance, the tracking contacts, the monitoring, the social distancing, other things also. So, we have the devices right now available with us, which actually termed as the buttons, which we called as the IoT buttons, for specifically designed for COVID-19 pandemic. So they usually perform surveillance and tracking, and robots, obviously, which decrease the man-to-man interaction by increasing the telemedicine approach, and human-less diagnosis performed, which has to be performed in a remotely here. And most importantly, this disinfectant spraying and the cleaning, which we usually done here. UAV drones and the wearables, obviously, which we are all surrounded right now in the current 21st century. So, to reduce the particular visits from the doctors, like we have the Alexa kind of artificial intelligence available with us. And we have such robots, specifically designed in the recent time itself. The social robots, which will decrease the mental stress here. Now, how is it going to fulfill? Again, the data analytics will come into picture. So they usually refer the different theories and the different problems, different senses of the people. How the people are thinking, and they just acquire different senses of the people, and they just apply the data analytic techniques, and accordingly they do the decisions here. We have another thing which is just like a robot, and in better we are known by the name of the collaborative robot here, right? And in short, it is termed as cobot. So these generally, the name is itself indicating the meaning here. These robots generally require the human intervention, because robots, cobots, not on their own completely, spray this disinfectant sprays to the remotely unreachable regions, and it also decreases the task of low-level work of the healthcare systems as well. And then again, we have the telerobotic machines also, which decreasing the possibility of spreading infection to doctors, nurses, and other healthcare workers from the patients as well. So here, I just need to summarize few points that we have the available wearable devices which actually combat the COVID-19 pandemic here. Which actually screen the lot amount of the people for generated symptoms, and which obviously will minimize the interaction between the patient and the person capturing the data, recording the location, monitoring the temperature, and so on. These are some of the pictures of the recent IoT-enabled devices specifically for combating the COVID-19. The smart helmet, you can see, smart glasses, smart thermometer, proximity trace, with respect to the ensuring the social distancing and contact tracing here. So all of these equipments are recently acquired by our Disruptive Technology lab, so that people can actually perform the actual experiments which can generate from the available data with respect to the sensing technologies and other, how people are thinking in the negative concern environment, and accordingly we can perform the data analytics and certain classification to control certain things there. Yeah, so these are the two I was explaining about. These are again recent two inventions based by this, specialized authors was Nasujupur Mohammed. So they recently introduced two IoT specific variables, which they are specifically calling it as a IoT buttons. So it is informing, better well, it is known by the name of Sefuki IoT button, which is informing the concerned authority or the respective families when the button is pressed. So this invention was recently introduced in China, where this button was given to the family of the COVID-19 patient when it has been isolated. So when it is being pressed, so the family members will come to know that something has happened to the concerned underlying patient here. Similarly, the other button, which was named after the name of a scientist, Wanda Quick Touch. So again, it is for the doctors and whosoever is the healthcare specialist in the front line, they will inform the emergency need of the patients here. So similar other inventions has been recently developed, although they are not actually commercialized due to certain other security and other concerns, but people are actually doing, in designing and developing such prototypes, because it is not something rocket science that we can't actually develop here just because we are in the COVID-19 pandemic. It has nothing to do with the COVID-19 pandemic. Just we need to understand what exactly is the requirement, and we just need to introduce these concepts related to the fog computing, IoT, and the cloud. Yeah, so we all know such recently smartphone applications also recently developed by the corresponding countries. And again, all of them are using the concept of the latency sensitive applications of the IoT as well as this here. Yeah, so these are some of the available other apps, which can be easily cited here. And apart from this, I just also wanted to highlight some of the drone services specifically for which are designed for this pandemic also. The types of the UAVs which are specifically designed for this COVID-19 management. I must tell you that recently one of our lab student has designed one UAV which was specifically designed and developed for spraying the disinfectants on the crop fields, usually in the concept of the precision agriculture. And now that same technology was recently customized by the same group of students to disinfect the sanitizer, to certain zones in a completely standalone way here. So it's not something that we can easily customize the things for the benefit of the society here. It's for surveying, social distancing, and other this particular thing here. So everything is possible. The only thing we need to understand the infrastructure settings of the fog computing and the cloud computing, and most importantly, the data analytics part. Once we have the data, so we should know how to classify into different levels and across other things at pandemic here. And what I can summarize few steps. Few generic steps. What exactly is required. So I cannot again dig deep into this technique because this is some of our recent work of our lab students, which is yet to be published somewhere. So, but this is very. These are some of the benchmark steps which one has to follow. That you have to always collect the samples of the infectious disease in the corresponding landscape, and you have to deliver the essential supplies in the epidemic-stricken regions using certain. Those students are using the blockchain-based framework, which was completely a Merkle root framework, and accordingly they have built a safety network through the collaboration between the drones and the IoT devices here. So collaboration is very important. That how you collaborate your physical layer world objects with the fog computing nodes using the different technologies related to the IoT and other things there. Now, let me explain you how exactly the training of drones usually happens here. So it says that if you have certain blockchain clients, so what do you mean by blockchain clients? So anyone has the capability of using the Merkle tree root, which is acting as an open source tool, whosoever is supposed to use the blockchain. So he can simply use this particular mechanism and the drone monitoring and the controlling mechanism. He can simply apply the encryption mechanisms and use this drone mechanism for spraying these disinfectant sprays using the blockchain concepts in different particular zones or in different particular clusters, as you can see, which we have built out here. So the pool of drones, using the blockchain consists of these three parts. So train of this drone network, the distributed blockchain network, the control system. So that's exactly is required. So distributed or blockchain network can also introduce some of the fog computing capabilities and the IoT networking capabilities itself. And thus the communication in this multi-drone system pass the information collected from the patients as well. So, yeah, this last recent contribution, I just want to highlight in front of you. So, this was a complete end-to-end delivery system using the UAVs here. So here, what exactly is happening that, usually you probably know this scenario that in another countries, these e-commerce websites have started now delivering the actual product through their so-called deployed drones. And this is one such recent attempt by us to just introduce this technology, considering the mirror image of those technologies here. Although we are partial successful, because the main challenge we were facing right now is with respect to the GPS positioning systems and how to adjust them dynamically and all. But although we were very successful, that our drones were very successful in detecting the quarantine areas and the containment zones, because somehow those are very static and usually doesn't change very often, even if we use after, let's say, a span of 20 days or after a month here. So this particular network has been divided into three particular parts. So the request for the essential items is generally, redirected to the blockchain layer, and the blockchain layer prepares the smart contract and passes the request to this particular DX layer, which we have termed on our own, the DX layer. And the smart contract is one of the open source software of the blockchain, where we can verify the conditions of the agreements which has been already populated in that software. And finally, we can use the another layer which we have termed as donate layer, which encrypts the request with such data and drone ID and estimated time, so that it passes the verified data to the blockchain. And from that software of smart contract of the blockchain, we actually acknowledge whether the delivery actually happened or something, what we say, that some relocation has happened dynamically and so on and so forth here. So this was our tentative framework, which we are continuously trying to put our efforts to actually realize in public, so that this can be realized here. Another, this surveillance of this COVID-19 spread, which we have actually done through this, that is detection of the maskless patients, and which we were very successful. Although we observed certain rate of false positive, sometimes, people were involved in other activities and they are covering through the face through some different things. So certain false positives got. But the false positive rate was very acceptable using this drone technology, and most importantly, by creating different nodes of the virtual fog nodes in this particular environment here. So this was all with respect to the, in conjunction with the drone technology and the IoT technology in the, particularly in controlling this pandemic here. So although the false positive rate is was there, but it was very acceptable, so that we can actually realize the actual potential of our underlying frameworks here. Yeah, so this is all about this complete talk here. So we started with the introductory part related to the IoT, followed by the challenges in the fog computing and cloud computing, and then we introduced the fog computing. We saw some of the use cases, and then we introduced this particular IoT, this infrastructure settings of the fog computing. We also understood the key applications of the fog computing. We also highlighted some of the the challenges in the fog computing, and how these two guys, IoT and fog computing, in conjunction with each other, are trying to combating this particular pandemic here. So that's all from my side. Now I'm ready to take your questions if anything will come from your side, and I want that something should come from your side so that we can create an open discussion forum where we can discuss these things. Thank you very much. This is all from my side. Any questions, any suggestions, any comments, anything which you want to discuss, anything which you have not understood, I'm ready to take. Please let me know. Yeah, thank you for your appreciation, but I would more appreciate if certain questions will come from your side. Yeah, come on, guys, please. At least the student participants can ask. I mean, so it seems that everything is clear to you, but that is obviously not true case, because it's a very long story. It's a very long journey for everyone. So please feel free to discuss anything.
Sir?
Yeah, please.
So actually, just I have one question about the
Yes,
cost
please.
effectivity part, and also whether the fog and cloud will be provided by the same platform, or we have to take separate platform for fog and separate for cloud.
Understood. So there are two things. First, you asked about the economical constraints related to the cost. So I
Yes,
must
sir.
tell
Yes.
you that fortunately, this is very cost effective. I mean, whatever I have shown you, the recent use cases, although some amount of funding is required for creating the infrastructure setup of the fog computing nodes, and obviously we need one independent server where actual computation capability has to be performed. So that thing we have already in our DT lab. But apart from this, we have to spend enough on this, specifically these drone systems. So drones are very termed to be very economically infeasible sometimes, and that is the way we got few rate of false positive. As long as the IoT devices, sensors, and some actuators, it is very cost effective. One can easily purchase, even sometimes from his or her own pocket, provided if someone is more motivated. But with respect to certain more actuators and sensors, which are very costly, and certain Arduino and other Raspberry Pi systems, these are somewhat cost ineffective. But if you are inclined with some academic institute, so definitely they can provide you the same. Number one. Number two, with respect to the softwares and the actual thing, so for the fog computing, there are n number of which I say the open application softwares are available to us. So there is a well-known consortium by the Cisco, which is very well known by the name of Open Fog Consortium. I am repeating, Open Fog Consortium. So in which so many players are there related to Amazon, Flipkart, Cisco, IBM. So they have their own fog computing virtual platform, which you have to purchase from their own. And that is again a one-time investment. Otherwise, if you want to do it on a small scale investigation, then you can also utilize the capability of one open source simulator, that is iFogSync. I'm repeating, iFogSync. But beware of this, because it is very restricted to few nodes. So if you want to do it on a level of achieving low latency and other things, so that obviously is not possible with this. So obviously you have to approach the open fog consortium, and you have to play. Consider certain virtual platforms. You have to purchase few platforms from those open fog consortium platforms. So overall, it is cost effective, but considering some situations of the drones and other actuators and sensors, sometimes it becomes cost ineffective as well. Yeah. Did
Okay,
I
sir.
answer
Thank you, sir. Sir,
Yeah.
and also just one more doubt I have. That is, if it is requirement is not so much low latency, then should we go for cloud only, and only in the case where you need very low latency like healthcare, as you have told, only that time we should think for fog.
Yeah, absolutely
Is it
correct.
like
See,
that?
yeah, absolutely. Let us
Okay, okay,
let us make one formal bottom line. If we have to make a one bottom line for cloud and for computing, so cloud computing is generally for storage and computation in a large quantum. But when it comes to the fog computing, usually we say it is for real-time applications which are more latency sensitive, which are more, which consumes high, low bandwidth and all. So obviously you are making a valid point, but I must tell you, nowadays no application exists which doesn't demand mobility, which doesn't demand low bandwidth, which doesn't demand low delay. I mean, you just tell me the name of one application which doesn't require any one of these things. So obviously, we have to introduce intentionally or unintentionally the fog nodes, right? So otherwise, we can use the cloud data centers as standalone commodity. But we have to introduce the huge communication distance, the high bandwidth requirements that we have to ensure from our end, right?
right, right, sir. So actually, just in case, I think this industrial application, as I am from this garment technology background, and there we have IoT in the garment section, garment machineries, where this automatic data capture is there, and there not so much low latency is required. Even after the end of the day, we can have this data in the remote device. So in that case, I think cloud is
Correct.
sufficient.
Correct. So here the latency issue is resolved. But what about the bandwidth consumption? Can your agency support high bandwidth requirements? If yes, then you can go for. But I must tell you that considering high bandwidth requirement is fine. But let's suppose if you are using low bandwidth on some days, that means you are not optimizing the usage of the bandwidth. Correct. So
Correct,
one
correct.
has to be
Yes, sir.
very careful that you have to use the scenario, but our prototypes should be very efficient enough, right?
Okay, sir.
That
Okay.
is,
Yes,
we
sir.
have
Yes, sir.
to, being, developer, we have to understand this thing. Otherwise, cloud is more than correct, right?
Yes, yes. Thank you, sir. Thank you, sir.
Hello. Hello.
Yes, yes,
Sir,
please.
this is Gajendra Simuri. Sir, my question is, can I apply data processing into the cloud or in fog?
Yes, we
I
have
mean
to
to say,
because
I mean to say, like actually, I'm getting data from the sensor, and now I want to apply some semantics on it using the ontology. So, can I
correct.
apply it?
Yes. So as I said earlier, that fog computing and cloud computing goal is not just to perform the storage and other achieving these goals. I mean, we have to do the computation also at these nodes. So that, see, we need to make this again one bottom line that fog is very closer to us. It is very closer to the ground level. So IoT devices, whatever the data which is sending out to these nodes, that storage and computation and efficient computation must be done at these underlying nodes, right? Because like you mentioned the semantics and other things, it has to be done. And otherwise, what is the motivation behind using these technologies, right? So computation has also been need to be performed along with these semantics and other data analytics part.
Actually, sir, my actually the motivation is that I want to give the meaning of data. Actually, I'm displaying data of the sensors, but now I want to give the meaning to the data using ontology semantic. So is it possible in a
Yeah,
fog or a cloud computing?
correct. I mean, this is completely. I mean, your earlier question was also in the same context. So
Yes,
I'm
sir.
again, yeah. So I'm again performing a rebuttal to that question, that it is 100% possible, because I mean, if you are not doing the I mean, computation capabilities, not integrating the computation capabilities, then we are only restricted to the storage part and the cache part. So obviously this is possible, because as you have seen that I have shown you some of the recent use cases related to the healthcare systems. So once the data has been sensed by the physical layer devices, so it has to be visible by the application, or sorry, the fog layer nodes. Unless they will not interpret the data, how will they will perform the computation? Correct. Are you there? Did I
Yes,
understand
sir.
you
Yes, sir. I
correctly?
got it. I got it. Thank you, sir. Thank you.
Fine. Any other question? Any other suggestions? Any other comments? Please let me know.
Okay, Dr. Shashank. I think no one
Fine.
is there.
Yeah.
Okay. Thank you very much, sir, for this nice talk on your very informative, I can say, your talk on the behalf of Department of Computer Science and IT, University of Jammu. I would give. I would like to thank you for this a very informative session, sir. Thank you, sir.
Yeah.
Thank you so
My
much, sir.
pleasure. My pleasure. Thank you.
Okay, participants, we will again join